worst spot. Everyone's waiting to have their drinks tonight. And I'm the last thing between today and all of the wonderful presentations and drinks, apart from a short panel, which I'm sure will be very short because people want to go and have a drink. But I'm very happy to be here today, and it's, it would be false to claim that I understood everything today, not being a physicist. But compared to a year ago when I was here for the first time, I've learned a lot, and that's mainly through the relationships that I've managed to build with a lot of the scientists, physicists and engineers that are researching quantum computing and quantum technologies. So I'm really happy to be here. For those of you that don't know Keysight Technologies, I have a couple of pieces of information. So if you don't know Keysight Technologies, you might know Agilent Technologies, and if you don't know Agilent Technologies, you might know Hewlett-Packard. We're beginning to see a bit of a trend here. Every 14 years we change our names. Okay? In 2014 we became Keysight Technologies, and there's still a lot of companies that still refer to us as HP or as Agilent. And when I go around and visit scientists and labs, I always see a lot of HP equipment from that time. I did work for HP for 7 years. Then I worked for Agilent, and now I've been working for Keysight, so I've been there around 16 years now at Agilent and Keysight. So in terms of the industries that we're in today, what we mainly focus on are the communications. It's industry, computer, semiconductor, and also aerospace and defense. And if I look at some of the work that I've been doing towards quantum technologies and investigating how we can better support the community, the needs there are very aligned. If I look at how we support customers from the simulation through the prototype and then to the optimization and the manufacturing, then that fits in very well with where we are today working with the quantum community. Chris mentioned before that we're investigating an opportunity to work with Bristol and with ICE Oxford to look into some more technology as we see things change in the market, and I'll talk a little bit about that. So if you put into Google quantum computers will, are, or is, you get a dispute in terms of the recommendations. But quantum computing in reality is no longer seen as belonging to the pages of some science fiction novel. It's more, we're seeing a big change. The last 18 months, we've seen a huge amount of investment around quantum technologies, quantum computing. Chris also mentioned before where the money's coming from. I could give you a lot more examples about that, but it's not a matter anymore of if, it's a matter of when, right? And what technologies. And I'm not going to talk about the different technologies, but we are seeing 4 bubbling to the top. That's semiconducting qubits or systems, ion traps, quantum dots, and then NV diamond structures and photonics. And those are the ones that we're seeing bubbling to the top. We're also seeing a number of innovative ideas around combining those, so having hybrid systems based on the physics behind those systems. So how are these quantum technologies affecting Keysight today? I mentioned before the markets that we're supporting today. If I look at some of the needs of those markets and the customers in those markets, then I see a common need, which is basically ensuring the reliability, ensuring the efficiency, and the repeatability. And this is consistent across all of these markets. If I look at what people are trying to do today, how they're trying to increase numbers of things, I see a lot of commonality between our markets and also the physics side, so quantum systems, quantum technologies, especially with the scalability and also with the size, weight and power. So if I look at some of the systems that some of our collaborators and customers are working on today, then we're looking, generally speaking, between 1 to 5 qubits, with some exceptions above that. If we move forward and we look at the test equipment that's being used in the labs today, then that doesn't scale. So if we're looking at 100, 1,000, 20,000 qubits, then we can't move forward with that. So what we need to do is make sure that we're supporting these areas as well. So if I look at the examples of some technologies, so Industry 4.0 is a good one to start with, because Industry 4.0 basically is about advanced communications, advanced connectivity, and also advanced predictions moving forward. And those are all elements that play a role and will play a greater role as we move forward and Moore's Law comes to an end in terms of some of the activities and developments that are going on from an R&D perspective there. So in Industry 4.0, we've got a few of the technologies which are also common to our customer base, but are also interesting in terms of how far can we go with classical computation today, in terms of the cloud, in terms of the Internet of Things, or Internet of Everything, as we're talking about now, and also 5G. There'll be a point where we can't do certain things anymore with the classical way. So I'm not saying that quantum computing and quantum technologies are going to eliminate the need for classical computation or technologies. It's going to be in parallel for a long time. There'll be, I envisage a few systems, if you will, less than 200 qubits that will be able to support certain specific tasks for that. And last week we had with EPSRC a workshop to identify, okay, where is that going, what's the direction, and our vision towards a quantum computer is obviously not tomorrow and not in the next 5 years. So the common denominators around an example like this coming from the industry is definitely the cryptography. We've talked a lot about that. Also the cybersecurity, artificial intelligence, the augmented reality, and also the predictability. And predictability obviously with companies like Google, Amazon, Facebook, and any kind of intelligence around those companies. And we're seeing a lot more investment from them recently. We've seen a lot of developments with IBM. Hardly a week goes by where 4 or 5 papers aren't published or articles aren't written. And we're seeing it's becoming rather dynamic. I can't keep up with all of the information that's being published right now. So common denominators, they're aligned well with our business model. I'm feeling very privileged at Keysight to be able to focus on a technology that is not actually around the corner. It's something that people have been working on for over 50 years, and I think the last 2 years have really seen a push in the experimentation, which brings me to my next slide, which is around our vision of the quantum computing. So I don't want to focus too much on the investment in billions. What I want you to focus on is at the bottom, the timeline. So we've moved away from the experimentation. We still obviously need to keep the theory, but there's a lot more going into the experimentation now with the engineering. And it's basically the start of the second revolution, as lots of people are calling it today. That means that we're having a lot more collaborations, a lot more R&D investment for actually creating something that we can commercialize over time. And a good indication of that is the support, the monetary support that we're seeing from a lot of government bodies as well as the industry for that. And also the first demonstrators that we're seeing. We envisage that the initial rollout of limited number of qubits, so let's say less than 200 qubits, is going to be around 2025 with a few, maybe 400. And that's going to be the initial portion where very, very specific and focused applications can be addressed, in our opinion. And then around 2029 to 33, 34, when I retire, that is when we're going to actually have the broad commercialization of the quantum computer. That means we're going to be able to address a lot more. And there are a lot of issues that we have to be able to address beforehand that we don't know about as an industry company. And that's why it's so important to make sure that we work together and collaborate, because there are a lot of things that you don't know either. A lot of the discussions today were, okay, we still don't know that, and it's the same with us. So it's kind of a learning process, and I'm very pleased to be able to work on that. So what does that mean exactly for Keysight? We've put like a concept together which we're calling a Quantum Computing Researchers Toolkit, and we started that about a year and a half, 2 years ago. So I did some investigation into the market, investigation into the applications, and I realised that we hadn't actually been very friendly in looking after the community. We'd been waiting until the community came to us and said, I need an arbitrary waveform generator with a sample rate of 1 gigasample or 12 gigasamples or whatever that was, and then we'd say, okay, there it is. But we weren't trying to understand the applications. Now we're trying to understand the applications, and we've realised that we can actually do a lot more to support the community, and that's what our goal is, and we've had our first successes. So the idea is not to come up with a solution that everyone has to buy, but to come up with a building blocks that you can add to what you've got. So the first one was basically, and I used the cat theme based on Schrödinger, right? And I do have my Schrödinger t-shirt on, but I've kept my jacket shut today. So copycat is basically taking the tools that we have and seeing how well they fit actually for the community. And that was step one, if you will. What we've now started to do is look a little bit more into how can we leverage what we have at Keysight, what we need at Keysight, where our gaps are. And the first steps we took last year when we acquired a company called Signadyne. They made arbitrary waveform generators and digitizers, and they support the community better because the cost per qubit, which means per channel, is much more attractive. So as we start to scale, that's going to be very important. We also see a lot of flexibility in terms of the making sure that we've got the phase synchronicity between the modules. We also have a modular approach, meaning you can upscale, take one card out, it's not a whole system. So we're able to support that. Moving forward, we're also looking at other opportunities. We're also working with other software vendors to make sure that we've got a complete portfolio of tools. We also have an open FPGA and software development kit that we've actually enhanced, and we're just going through the next generation of that to make sure that we can better support the community here. Then the next version, and obviously there's going to be multiple versions of this, is Cat in the Hat. That's talking about how can we take the technology that we have today and ensure that size, weight and power are going to be taken into consideration. How can we make sure that moving forward, as we increase the number of qubits and the intensity and the bandwidth, how can we make sure that we're a part of that? How can we make sure, for instance, that we can embed some of the technology to cryogenic temperatures so that we can be smarter at the work that we're doing? Because at the end of the day, what we're going to need is a certain amount of measurement intelligence in the quantum computer that's going to be shipping at some point in 2030, 2025, whatever that number is. So we need to make sure that we're working on that now because we're a public company, but we obviously need to take some of that information and make sure that we're paying attention so that we can build that into our R&D processes now. So I'm basically taking a lot of inputs right now for some of the future requests that are coming in from customers depending on what their physical approach is. So we've basically got a few toolkits already available. I don't want to go into too much detail here. I don't want to do just product here, but what I want to say is that we've put a lot of thought behind making sure that we're not doing a unique product or solution for one customer, which is very niche. What we're trying to do is find a solution that fits 70% of the customer needs for the major implementations, and then obviously there's going to be something that we need to put on top of that at some point. We don't have everything today. Software, hardware, FPGA integration, etc. So that there's like a common platform as opposed to everything's a one-off, which means that it's going to be very easy for the experimentation to also scale. So the multiplex of waveforms, you can take some of the software that you've already got, build that into your FPGA, and you can also utilize that with existing equipment. So basically there's a few basics that we've learned around what's needed from a software perspective, how we can better support some of the issues that are being had today in regard to error correction. Also the ultra low noise of the RF waveforms that are required, and a few of those kind of aspects as we move forward. So I'll jump over that one. This is a simplified scenario of implementation, and what I wanted to show you here is this is actually MIT. We're using Labra in that example. We've got an arbitrary waveform generator, we've got digitizing them, we've got the local oscillators, and then the digitizer and the FPGA are then passing back the signal. So basically, what we can see here is our first demonstrator. We showed that first time at European Microwave Week last year in London, and the second showing was at AP's March meeting a couple of weeks ago. So, in order to make the technologies real, obviously we need some industry partners, and we do focus obviously from an industry perspective and try and take the information that we're getting to make sure that we can realise some of that. The most important thing is the people and the collaboration, and I think it's a very tightly knit community, and I'm really pleased with the advice, guidance and support that I'm getting from a lot of researchers that I've spoken to, giving us a little bit of help to better understand some of the physics, even though we do have some physicists that we've hired in the meantime. We're seeing the technological advances, and one thing that I think we all need to work on is the communication and the education. So I think within our community, I think we're very good at doing that, but technologies, quantum technologies as such, are not that well known outside our community as such, meaning if I talk to somebody a friend of mine, and then it's like, oh, what's that, and what does that mean? And there's very little knowledge. So I think that we need to, as a community, start to have a broader reach on that. And I'm seeing that with press releases or with articles that are more publications in magazines rather than being technical articles on the archive. So just to summarise, we're committed for the long haul here from a Keysight perspective. We really want to support the community. The only way that we can do that is do it as a phased approach, because we don't know what's going to be in 5 years, what you're going to require. We want to make sure that we're providing a choice, and we want to also avoid you having to make classical test equipment that should be our job. We want you to focus on the science, so to speak. I'm planning on a workshop from a Keysight perspective addressing the 4 major approaches, because I want to make sure that I'm feeding into our planning as the Quantum Technologies program director. I want to make sure that we're feeding that information into our R&D and into our planning 2 to 3 years in advance. So if anyone is interested in participating in that, please let me know. Either speak to me in the coffee break or send me an email, and then we can keep the discussion going. In terms of the Keysight representatives, obviously I'm in Germany, but that's not that far. I come to the UK quite frequently. Raj Kapilani is our Solutions Business Development Manager. He's based in Winnersh. Guy McBride is our System Architect here in the UK, and Anthony Page is our account manager, or one of our account managers, specifically now for Bristol. So those are the names that I wanted to share with you. So, thank you very much. Anyone wants a drink?
If not, let's thank the speaker because the next session is so great. So